This is a video about making shot shells. The first step is to plan what to make, how many, depending upon how many I have in stock, and to gather the materials. These are the boxes used to store 25 shells. I have about 25 of these. I use probably 4 of them for each time I go to the shooting range. I keep 10 each in these ammo boxes. 10 boxes of shells is called a flat. I keep the other ones in this closet, my gun cabinet. This is not a gun safe, where I keep guns and all the materials. Powder, primers. These are materials. These are chokes for shooting, Remington, B&P, and Monarch shells. These are the extra 5 containers on this, kept on the side. They have 25 shells. They also have labeling to tell the type of powder, the wad, the shot, and the date they were done. Generally, when I need materials, I need both powder, which is kept in large 8-pound jugs, and approximately 1 pound is kept in this MEC bottle. I get the MEC bottle of powder and I use the powder over and over again until I run out of an 8-pound jug. I also need primers. The primers make the flash that cause the powder to ignite. I'm using, right now I'm using Win 209, Winchester 209. They fit the type of shells that I use. The primers come in boxes. Each box has 100 primers. This box has been partially used. So it's got approximately 50 timers left. I'm going to use 25. This demonstration will use 25 timers. So I'll take the box and put 30 timers out. I have 30 primers out to use. These are 100, and I have a stash of about 3,000. Lasts for about 3 months. All right, so primers and powder come from my storage area. There are 5 components to a shot shell. The hull, which is the outside container, a primer, which has explosive in it that will explode when it's hit by the trigger in the shotgun. Powder, which is which burns at a very high rate and causes pressure in the shell to force the shot out. A wad put on top of the powder, which carries the shot through the shotgun, and shot, which is the shot of the shotgun. I keep the hulls stored in an area in 2 ways. These are hulls that I picked up off the shotgun course that someone else has shot. These are Remington Nitro hulls, which are a good shell for reloading. And these are Remington Gun Club hulls. Both shells have been picked up off the shotgun range. I also keep a box filled Remington shells, both Nitro, Gun Club, and STS are tapered shells. They have an exterior plastic hull The interior has a taper down to the bottom. The powder fits in the taper, and the wad goes over the powder. The other kind of shells I use are straight wall hulls. I have tons and tons of Monarch and a few B&P by Sherry and Pelagi. The Monarch shells are a straight wall hull, meaning that there's no curve at the bottom of the hull. The Monarch shells are an inexpensive shells purchased from Academy Sports. They're found in at shooting ranges near Columbia, South Carolina, where there's an Academy Sports. The B&P shells also can be found at shooting areas, but they're less frequent because they're more expensive. I also shoot commercial B&P shells and then pick the hulls up and use them later for reloading. Another component is the shot. I have two kinds of shot, and I probably have around 30 bags of 25-pound shot. One of them is Hepper shot. It's 6% antimony, which means it's fairly hard. The other one is STS shot, made by Remington. STS shot, STS stands for skeet, trap, and sporting. It's also 6% antimony. I probably have about 25 bags of Hepper shot and maybe 5 or 10 bags of STS. So now I have the powder, the primers, the hull, the shot. And the last thing to gather is the wads. The wads are a piece of plastic that are put inside the shot shell. These are wads for tapered shells, the tapered Remington shells. The bottom part of the wad fits on top of the powder and slightly compresses it. The top part of the wad holds the shot. The shot is then, when the primer ignites the powder, the wad is pushed out with the shot through the shotgun barrel. The wad is basically the device to capture the power of the burning powder and project the shot out of the shotgun shell. I have several kinds of wads. These white ones, CB 4100, are for the Remington shells. The 12B stands for 12 gauge. CB 41 stands for the type of shell, and the 00 indicates these are 1 ounce shot shells. CB 6118 are for the straight walled shells. The 18 refers to 1 1/8 ounce 12 gauge shot. The 12 is a 12 gauge. I also carry CB 6112. Again, the 100 stands for 1 ounce. The 12 is a 12 gauge. I also have some 41 1/8. Why the different sizes? It turns out that some of the powder that I use is very dense and does not load properly with the 1 1/8 shell. The 1 1/8 wad is shorter, and the powder does not pack up high enough for the shot to stack up, where the 4100s and the 6100s are for 1 ounce, and they have a higher shot area. So the type of powder I'm using, high gun, generally needs the 1 ounce wads for 1 1/8 ounce shot shells. The B and P hulls have a smaller volume because of an insert, a special insert in the shell. So for those, I need the 1 1/8, which is shorter and the smaller, fit in the smaller volume shells. I have backup of these. I usually keep a couple bags of each. There are 500 wads in each shell. If I shoot 1,000 shells a month, I might use 2 of these bags each month. This is my reloading area. I have a stool. This is the MEC Sizemaster. The MEC Sizemaster includes a place for the to put the shot and powder bottles, the charge bar, which moves back and forth to deliver shot, powder, and shot, a primer tray, which when this is operating in the standard manner, opens up, drops a primer into the primer tube when the last station is used. However, I have not been able to use that very effectively, so I tend to place my primers on the base of the tray and pick them up one at a time. There are 5 stations. Each station takes a shot shell. The first station is the deprimer station, takes out the old primer. I'll demonstrate these later. The second station puts a new primer in. In the third station, the charge bar is put across to drop the powder. A wad is placed into the hull. I won't put this in because I don't have shot. When the wad goes down into the shot shell, the charge bar is pushed back and the shot drops into the primer, into the shot shell. In the standard procedure, a pre-crimp step with a crimp spindex is put onto the shell, and in the last station, a final crimp is done. I've modified this procedure, which I will demonstrate, to have 2 additional steps. One step following the shot is to use a GAEP product. This is the GAEP rotating star crimper, and instead of the pre-crimp step on the MEC Sizemaster, I put the first crimp with the GAEP. The shell is transferred into the place where a GAEP ribository is placed in place of the spindex. I'll demonstrate later what that does. A final crimp is done. The shell is then put in a drill press, which has a BN2 BN2-12 taper crimp, and puts a nice taper on the shell. This is the reloading area. This is my tool bench. In the reloading area, I have the Sizemaster. I also have a leather punch drill, a leather punch press, which has the GAEP BN12. I do 50 shells I do the shot shells in group of 50. I do 50 D prime and prime. Then I do 50 powder wad and shot. Each time I do a powder wad and shot, I put one in these holes, and there are approximately 50 holes. After I do 50, then I do the crimp step, the rebascitory step, the final crimp step, and then the BN2 taper crimp. So this is the Sizemaster is in a cake pan and a knife cutting board, and that's the kit shot. And actually you can see here, there's shot left over from the last time. I use a vacuum cleaner to clean this out. The pre-crimp step with the press is put in a box in which I've drilled approximately 50 holes, so I can do 50 shells at a time. I have a number of, this is the desk. This is a desk from a tool store called Harbor Freight. The desk came with 2 drawers and the empty, and then the bottom was empty. I put in 1, 2, 3, 4 drawers that come from computer rack. Each one of these drawers has things, and these have the tools that I need for the preliminary, for the shotgun making. These have some marking tools. I keep the bottles in here, empty bottles, and these have a couple of devices that are too large to fit in the other. I also have a shop area that I use quite frequently, a toolbox with a number of tools that end up being used on this procedure as well as other procedures. There's some miscellaneous tools, a place to store the wads. Wads that are in open bags are stored underneath, as well as shot is stored in some shot is stored in a container bag. In addition to that, I have a workbench, which includes a whole set of power tools and other tools. The drill press that right now is adapted to be used for the final crimp station. The work area is in the garage. I have to pull one of our cars out onto the driveway in order to use the work area. I try to keep this swept off and clean so that I have a nice workbench. Those are the preliminaries. I'm going to set up the Sizemaster to do I'm using 2 kinds of shot. One kind of shot is called Hepper. Hepper metal is made in Turkey, shipped to a store called the CAC Associates, and then shipped to my house. The other shot is Remington STS. Both shots are Remington STS is made in the US by an American company, Remington, and is bought from a internet store that sells reloading materials. Both the STS and the Hepper shot are 6% antimony. They're take slightly less volume per shot, so that more pellets fit into 1 1/8 ounce shell. Actually, the same number of approximately the same number of pellets weighs 1 1/8 ounce, but their volume is slightly different. A regular 1 1/8 the MEC loaders have a piece called the charge bar. The charge bar usually has a number on the side. This says 302100. This is for a 1 ounce load. This charge bar says 302118. This is for a 1 1/8 ounce load. This charge bar says 302118. This charge bar is an initial charge bar. The 1 1/8 ounce will fit number 8 shot of 1 1/8 ounce in the charging buffer, charging hole. Heifer shot, which is has less volume than the Eagle 4% shot, and different than the STS shot, has to have a specially designed hole drop area for the shot. And you can see I've drilled out area at the bottom. This was a 1 ounce shot, drilled out both at the top and at the bottom with different circumferences in order to drop exactly 1 1/8 ounce of shot. Currently, I was using STS shot, and the charge bar in the machine is STS shot. I'm going to take that charge bar out and use the Heifer shot because I'm about ready to change to Heifer. I'm going to do that. I'm going to put the camera on fixed mount and then do the change the charge bar for the Heifer shot. The charge bar is attached to the MEC Sizemaster with a small bolt. Loosen the bolt. This is the device that keeps the bolt from going in when the handle is in the up position. I'm going to remove the charge bar, but to do this, I'm going to tilt the bottle holder back and pull out the charge bar. The reason I'm pulling the bottle holder back is that there's a small brass washer inside the charge bar area that needs to stay in order to keep the powder from falling in. When I pull this out and it's upright, that falls down and I have to re-put it. The charge bar has a bushing. The bushing is in the powder area, and the bushing is what controls how much powder is. I'm going to change the shot bar, pulling out the old shot bar for the STS shot and putting in the charge bar that I've marked with an H that's designed for the Heifer shot. Replace the bushing. Now the bushing is in the charge bar. Put the charge bar oriented correctly back into the machine. Hello. The brass washer fell out. I'll try to replace the brass washer into the shot delivery area. I can't do it, so I'm going to have to redo. This is called a baffle. It's used to allow to have powder drop consistently. Inside the place where the baffle sits, there's a rubber grommet and the brass washer that go in. I will replace the charge bar in its correct orientation. Drop the bash washer in with the nipples up. Put in the rubber grommet. Make sure it's seated correctly in the hole. It is. There's also a rubber grommet in the baffle. The rubber grommet in the baffle contacts the rubber grommet in the hole to create a tight seal. Make sure the charge bar slides back and forth. It's a little tight. Put the charge bar stopper back on. Tighten it. Later, I will put the powder on as well as the shot. Insert the shot. The bushing that is in this is set for the Remington holes. And I'm going to leave that bushing. It comes from the last time. This is a different bushing that's set for the straight holes. I'll be back in a bit with more. When I'm finished with everything, I need to clean out the dump shot. I did not clean that out from the last time. Probably in a hurry. There's pellets that have fallen out and powder. I have a DeWalt shop vac, a small handheld vac that cleans the powder out. I put this attachment, which has a thin edge. I've gathered 25 empty hulls. These are Remington Nitro hulls. They're very good for reloading. These have been reloaded. These have been shot once with the commercial shot and reloaded once. So this is a second reloading. The procedure to do this, if I went all the way through, which I'll demonstrate later when I have the powder in, is to deprime, prime, powder, shot, crimp, rubacitory, crimp, and then the drill press. However, I break these up into sections. It's a little bit faster, and it also makes my reloading more consistent because I do one task at a time. The first task is to put the primers in. I take the primer box, I'm going to do 25 primers, so I'll put 30 out onto the tray, 10, 20, 30. These are in slots 1, 2, 3, 4, 5, 6, 7, 8. Put the tray on the front of the primer. Go out 8 steps, 1, 2, 3, 4, 5. 5 empty sets, 3 with primers, and there I have 30 primers set out. I'm only going to do 25, so there'll be 5 primers left at the end. I'll put the primed shells next to the container so that they're easily picked up in the other parts. Here I go. I'll do a couple, turn the video off, and time this to give you an idea of how long each step takes. There's my stopwatch. I'll do a couple first and then do the timing with the watch. D-prime takes the primer out and resizes the shell. This is called the collet. It makes sure that the shell is made smaller during the shot. When the shell is shot, often the base or the plastic will expand. Place a primer by hand in the priming area. Shell goes on the tube, hole goes on the tube, press it down, and we have a shell with the new primer. All right, I'm going to do 25 of these, and then I'll come back later. All right, let's start the timer. I'm on my last 2 shells. Take about 3 minutes. Last 2 holes. Three minutes and 4 seconds. There are the holes laid out. I put them in groups of 5 so I can count 25 easily. I'm doing 50. I have another 25. Or I use this box, which fits exactly 50. I have 5 shells left over from the 30 on this platform. I'm going to put them in the hole in the automatic shell, primer tray, which I don't use, but I do sometimes drop primers manually. All right. The next step is to put on the powder and the shot bottles. I store the shot in containers like this, with the Hepper shot back on the bottom and on the sides. And I store 25 pounds of shot in this used powder jug. I'm changing to the Hepper shot from the STS shot, so I'm going to have to put the Hepper shot in the bottle, weigh it, make sure that I'm getting the right weight. Place the shot bottle on the Sizemaster. This lid is on the top and is a Richard's peanut butter jar that has been attached to the top of the bottle to make it more sturdy. I will take the shot out of the powder jug and put it in this. One jar of this is somewhere between 25 and 50 hulls. I'm pouring it in. Lid back on the jug. One jar, this jar is approximately, is filled with shot. That's approximately 50. Use a funnel and into the shot bottle. I know from experience that that's approximately, that halfway up the shot bottle is approximately 50 shells. Right. Put the lid back. I'm going to leave the lid off for now because I'm going to test the drop of the shot to make sure it's right. A digital Hornady digital bench scale used to measure the shot in the powder. Original container with original plastic container. Power supply. Digital scale. Turn it on. Has a zeroing function. I'm going to use the zeroing function. I put a empty hull, primed hull on it, zero it. Take the hull and put it in the shot drop. This is the powder. There's no powder here. This will be the shot drop. Measure the weight. 400. Put that back on. This is 493 grains. That's nearly exactly 1 1/8 ounce. So my charge bar is working. I'll do this twice more just to make sure. 0. Shot drop. Weigh 492. Shot back in the dirt, in the bottle. 0. Shot drop. Weigh 486. There's some variation in the weigh. 486 is about 4 pellets, so that's fine. Shot back into the bottle. Put the lid back on. This spills would be a mess. Always make sure the lid is back on. Next step is to put the powder bottle on. The section with the charge bar and the powder bottles is tipped back. And make sure that the lid is on and that you hold on to the powder bottle, the shot bottle as it goes back. I keep about 1 pound of powder in this at a time. It's just convenient. Presumably you're supposed to empty this out every time, but I don't do that. Powder bottle goes in. When the charge bar mechanism is tilted over, tipped up, holding on to both bottles. And now when the charge bar is slid over, the first charge will drop the powder. You're going to check the powder drop a similar way to that I did. I'm taking off both lids. Zero or prime shell. Put the prime shell in the powder drop area. Drop the powder. 18.9. The weight of the powder is based on a formula done by Hodgson, and this is supposed to be somewhere between about 18.5 and 19 grains. So that is satisfactory. Put the powder back in. The shot is now going to drop, and it's going to just drop in the empty shell, empty hull, so I can replace it. Zero the hull. Powder drop. $19.6. So I have about the right amount of powder coming out. I'm satisfied that the powder is correct. I actually chucked the powder drop, weigh the powder drop 3 times. Once at the beginning, like in this procedure, after the 12th, on the 13th hull, and on the 25th hull. This is just to make sure that we're having consistent powder drops. Powder back in the powder bottle. Drop the shot back in the powder bottle. Lids. The purpose of the lids is to keep the powder and the shot from dropping out when this is pushed back. I always conscientiously put the lids back on every time because I don't want to have to think about it when I'm dropping. All right, now I'm going to do 25 shells. I'll reset my clock to 0. I'll do a couple and show you. Actually, now that everything's set up, I can go through the whole procedure. I'll get a new shell. And this is. I will step through the whole procedure for one shell. As I mentioned, I do this this breaking up the steps, partially for speed, partially to consistent, and some other reasons. So, take out the hull, insert the primer. Hull goes underneath the shot and powder dispenser tube. Dispense the shot. Put a wad on the wad dispenser. Dispense the shot. And we have shot and powder both in the hull. Usually I put these in a hole, do 25 of these in the hole, but in this case I'll go through the rest of the procedure, do the priming, the preliminary crimp. By the way, I have a 6-point crimper which does six petals on a new shell. On a previously fired shell, it does a number of petals that were on the previously fired. The next step is the ribber store. The ribber store creates a cone of the 8 and creates a small place around the rib. The next step is the original can. That's what a shot shell would look like if I had stopped at this procedure. The last step is to put on the taper crimp. The hull to below holds the shells. Right now that shell is spinning, but usually I put some oil, and now I have a taper crimp, which puts a roll around the edge of the crimp. Often I will check the size of these. This is a Lyman ammo checker. If the shot shell should go in this slide in this side, and should be too big to slide in this side. Oh, let's see what happens. Falls down into easily. Too large to go into the other side. Now that's a good shell. It's completely done. All right, now I'm going to do 25 of these. First I'm going to do the 25 shots and place them in the holes on the primer crimp board. I'll do two. I'll do a couple. Start my clock. Turn the clock off. I'll turn the camera off. Do the rest and turn the camera on to the end. All right, here we go. Forgot to turn this on. I've done two already. Powder. Shot. Placed on the crimping board. Powder. Shot. Placed on the crimping board. I've done 12 of these. This is number 13. I'm going to go through the process of weighing number 13 to make sure, whoops. I've done 12 of these. I'm going to weigh number 13. I'm weighing number 13 to make sure that the powder drop is consistent. And at the end, I'll also weigh the shot, the 25. So, 0. Drop the powder, 19.4. So we're in the same general grain area. All right, back to, I paused about halfway through, about 2 minutes. I paused the timer so I could do the weight, get a good time. All right. So this shot, this shell, hull has the powder in it. I'm gonna finish. Place it back, start my timer, place the shot, do another one, with the shot. I'm on my last 3. I'm going to pause the timer. I have 3 wads left. The 25 watt, the handful of wads that I pulled out was exactly 25. Happens quite a bit. All right, I'll do the last, start the timer back and do the last 3. Four minutes and 25 seconds. I forgot to weigh the last one. That's okay. I'm sure that it works. That's the shell I finished earlier. There's exactly 24. The way that I count these is I don't have to count them because there's exactly 10 holes there. 10 sets of holes. That's 20 shells, and there's 4 shells. And then I'm going to do the next step by doing the crimp on every shell, and after I do the crimp on every shell, then I'll do the parts on the Sizemaster. So I'll do a couple of crimps here to show you the crimping, and then turn this off. Start my timer again. Pull that down until I hit the crimp. It's a nice crimp. Pull down. Place the shell. Pull down. Place the shell. On the last 3, 2 minutes and 45 seconds. Just shell. Go down. Place the shell. Go down. Place the shell. 3 minutes and 4 seconds. There's 24 here. The next step is to take them out, put them in the ribostor step and the crimp. Place them in the container. I'm not going to time this. It takes about 3 minutes to do this step. I usually pick up 4 at a time, as I can put them in my hand. One, 2, 3, 4. Place one under the ribostor. Place under the crimp cam. Toss it. One. Toss it. One. That's the crimp. That's a pretty nice crimp. It's preserved all 8 petals, folded. The depth of the crimp is fine, and the little roll around the edge. One, drop it. Now I'm going to do the rest of the 20. All done. 25 shells. 3 minutes to do the D prime and the prime, 4 minutes to do the shot and the powder, 3 minutes to do the crimp, ribository, and cam. So approximately 10 minutes. These shells are ready to fire. I could take these to the range now and fire them. I'll come back later and do the final step and then the cleanup. I'm back. I took a break. At this point I have 25 shells. I could stop. Remember, that took me about 3 minutes for the prime, D prime and prime, 4 minutes for the shot and powder, 3 minutes for the final step, the crimp step. So I could do, usually if I do this and I only do that, it takes about 12 minutes total. At the end of 12 minutes, I have shells that are comparable to the shells with the standard MEC Sizemaster procedure. I have an extra step, which I'll do in a few minutes, but I want to give you a couple explanations. One explanation is, why do I do the primer step, D prime and primer step, separate from the powder and shot step, and separate from the crimp step? One reason is that the charge bar has the powder bushing and it sits right underneath the powder. If you pull the handle down multiple times, which would be D prime, prime, powder, shot, pre-crimp, and crimp, the powder, more powder falls into the powder bushing, and the weight of the powder in the shell is too large. So in order to keep that consistent, I have this step for, I'm gonna do a shell first. Drop the shell. And I'll go through all the steps. E prime. Manually drop a primer from the primer tray, which I have to have the primer tray pulled down. Manually drop the primer from the primer tray. Prime. At this point, there's been two shakes of the bar, which causes extra powder to fall into the bushing. And now do the next two steps. The next step is the powder. Wad and shot. First crimp step. Two pulls of the handle. And more powder has fallen down into the powder bushing. So, and I also have two additional ones with the next E prime and prime. There's two ways to solve this. One way that I've solved it is to do these two steps separately, these two steps separately, and the powder and shot separately. Watch what happens then, how that works. In this case, the bar is pushed back, powder, shot, and that's it. And the powder, shot. Now the charge bar has only been pushed back once, and the powder drops into the charge bar. So that extra powder does not drop into the charge bar. There's another way to do that. When the charge bar gets moved back, I've shortened the part of the charge bar that stops the charge bar from going all the way across. I can push the charge bar back and the charge stopper stops short of the hole that the powder and shot hole. The charge is now not under the charge bar. The powder is not under the charge. The powder bushing is not under the bottle. So now I can pull the handle multiple times and the charge will stay the same. The powder will stay the same. When I drop the powder, I get a consistent powder. That's another way to do that with doing all 5 steps. Next, there are about 4 ways that I can do the crimp. The way I'm doing it now is I have the pre-crimp from the GAEP. I have the rebassatore, the cam on the MEC, and the final taper crimp. I can skip some of these steps. I can skip the rebassatore step on old shells. On new shells, new hulls, that step is critical to create the cone and the rim around the edge. It's not critical on previously fired hulls because they already have the fold. So previously fired hulls can go direct from the GAEP pre-crimp to the crimp and then possibly over to the BN2. The second way that this can be done is that we could do the crimp, rebassatore, and skip the crimp on the MEC machine. The final BN2 would do both the crimp and the taper crimp at the same time. So that I'll do those two and show you the result. All right, so here's the 4-step procedure. Crimp. Rebasator. MEC crimp. And taper. Finished shell. Now I will do it. I will skip the rebasator and go directly to the MEC crimp. Pre-crimp. Skip this step, go directly to the crimp. Looks pretty good. It's not perfect. It looks better doing them both. And then use the taper to do the taper. That looks pretty good. Probably okay. Third, I'll only do 3. GAEP pre-crimp. Pull that out. Rebasator. Skip the MEC crimp, and go directly to the BN2. The BN2 does not do the crimp as well as the MEC crimp, so I'm going to go take this back. Use the MEC crimp, which crimps down better, followed by the roll crimp, followed by the two. I get the best results by doing the 4 crimp process: pre-crimp with GAEP, rebasator, crimp with the MEC crimp, and the BN2. All right, the next step is to do the 25 shells. I'm going to do each shells one at a time. The first step is to put a little bit of 3-in-1 oil on a cloth. Turn on the BN2 drill. Take a shell, get a little bit of oil on it. Getting oil makes these part work better. And the shell will not turn as much. So got a shell. Another one. I'm going to set this here so you can see. All right. All right, a little bit of oil. Done. I usually place this in a holder. This holder allows me to mark the shells at the end and also keeps track of 25 shells. Sometimes, after I do a shell, if something is odd about it, I might use a live and shell checker. Drops right in on the correct side, and the other side it does not go in. So that shell is good. I'll put these shells in the shell box just to keep them orderly. Do a couple of the the taper crimp and then turn it off and do the rest. Taper crimp, taper crimp, taper crimp. Occasionally the crimp will poke out, and in that case I put it back into the MEC crimp in order to get the flat crimp. Do the oil, taper crimp. All right, I'm going to start the stopwatch, do the rest. I've done 5, there's about 25 left. I'll come back when I'm finished. All right, about done. 4 minutes. That was the final one. I have more than 25 shells in this because I was doing the demos. Shells are marked. A shell with no mark means that this is a new shell that has fired once and not been reloaded or taken out of the bin. A shell with 1 line means this has been reloaded once. The shells here have numbers. The shells with numbers were reloaded once. I was doing a test. Now I'll put double marks. Shells that have been fired once, that have been fired once and just reloaded once, get a single mark. The shells that have been fired twice, reloaded twice, get 2 marks. The shell, 2 marks. All 2 marks, 2 marks, 2 marks, 2 marks. All of the shells with number I'm going to mark once for their 1 time. That's a single line to show that they've been done once, and this is a second line to show that they've been done twice. This is usually a little bit neater because I don't have a pre-existing number mark on them. I can do them by running this felt tip marker across the entire shell, but right now I'm trying to just make sure I get 2 marks. The reason I'm marking them, some hulls I have do not hold up very well, and I can only do like 2 reloads and I have to toss it. Some shells I can get up to at least 5. The 3rd time I'll put a 3rd mark on it on the shells that I'm going to reload more often than twice. The 4th time I'll put a cross on it, and each time after the 4th time I won't put a mark on it, meaning that at any time I should throw this shell away if it's broken or not performing. The last step is to load these in the box. I have a stacker system, and I have 30. I can put 25 in a box. I will go ahead and stack these, alternating the base and the crimp. This also usually goes faster. Crimp, base, 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 crimp, base. You could take a box, empty box, and place it over this shell stacker, and then use the empty box to fill up the empty box. This is a shell stacker box. I don't have a lid on this one. I have 25 of these, and they're all filled up in the cabinet downstairs. Shell stacker box. Fits on the shell stacker. Turn it over. And you have a box of your 25 shells. Put the shell stacker lid on. I usually label them and tape it so I know what kind of shell is there, what kind of powder was used, and the date. There's 5 extras. I'll just put them somewhere in the cabinet. I usually do, when I shoot on a shooting clays range, I shoot at least 100 shells, sometimes 125. I usually do 50 at a time. This holds 50 shells. So if I've shot 100, I'll do 50, 50, and then do the 100 and put them in these 2 of these shell holders. I can do, it takes me about an hour and a half to do 100 shots on the clay course. It takes me about an hour to do 4 of these. There are faster ways to do it. I feel this way gives me the best crimps and the best shell. All right, I'm going to put everything away. I won't go through that with you. That includes taking the shell into the cabinet upstairs, putting all the equipment that I used away, the scale, the boxes, taking the powder off. I leave the powder in and take it downstairs. Taking the shot off, I put the shot back into the powder jug. Vacuum. You can see here that at one point I spilled some shot, and this box is usually filled with empty with primers that have been used. I've already emptied the primers. 1, 2, 3, 4. I have 4 or 5 pickle jars of primers from my time, about 13,000 shells. I'll do the vacuuming, everything will be put away, and then I'll be finished. And I think that's about it. Oh, that's my story, and I'm sticking to it. One additional note, my vacuum cleaner has a HEPA filter inside, and the shot that's picked up is kept in this container. Every once in a while I take the container off, put the shot through a strainer. There's a strainer. The dust and powder fall through the strainer, leaving the shot, and I recover that shot. I can probably get about 2 shells worth of shot every time I clean this off. 2 shells isn't worth very much, but it's a way to just keep things flowing.